Imagine a world where the very laws of physics as we know them cease to hold sway. A realm where particles can exist in multiple states at once, where information seems to travel faster than the speed of light. This is the captivating and perplexing world of quantum physics, a realm that has both baffled and inspired physicists for over a century. Our journey into this extraordinary domain begins with a captivating phenomenon that challenges our classical intuitions: the observer effect. Imagine shining a beam of light on a tiny particle. Classical physics tells us that the light should simply bounce off the particle, allowing us to determine its position. However, in the quantum realm, the act of observation itself influences the particle's behavior. The very act of measuring the particle's position affects its momentum, and vice versa. This inherent uncertainty is not merely a limitation of our instruments, but a fundamental aspect of the quantum world. This strange behavior begs the question, what does it truly mean to observe something in the quantum realm? Does observation create reality, or is there a deeper truth waiting to be uncovered? One of the most fundamental and mind-boggling concepts in quantum physics is wave-particle duality. This concept states that quantum entities such as photons, particles of light, and electrons exhibit both wave-like and particle-like behavior. This duality is famously illustrated by the double-slit experiment. In this experiment, a beam of electrons is fired at a barrier with two narrow slits. Behind the barrier is a screen that detects the arrival of the electrons. If electrons behaved solely as particles, we would expect to see two distinct bands on the screen, corresponding to the two slits. However, the experiment reveals a far more intriguing pattern, an interference pattern. This interference pattern, characteristic of waves, suggests that the electrons are passing through both slits simultaneously and interfering with themselves, much like ripples on a pond. But how can a single particle pass through two slits at the same time? This question highlights the inherent strangeness of the quantum world and the limitations of our classical intuitions. Closely related to wave-particle duality is the concept of quantum superposition. This principle asserts that a quantum system can exist in multiple states simultaneously until it is measured. One of the most famous illustrations of superposition is Erwin Schrödinger's thought experiment known as Schrödinger's cat. Imagine a cat placed inside a sealed box along with a device containing a radioactive atom. The atom has a 50% chance of decaying within an hour. If it decays, it triggers a mechanism that releases a poisonous gas, killing the cat. If the atom doesn't decay, the cat remains alive. According to classical physics, the cat is either alive or dead inside the box, regardless